All right, these are the notes for 3.5. Now we're going to solve a nonlinear system, which means one of the equations in this system, at least one, are not straight lines, okay? So we might be given two equations, well, we are given two equations, and our solution is where they intersect, okay? It's the point that if I plug them into the original equations, it will work for both. It'll make them both true. So if they only intersect in one spot, there's only one solution. If they don't intersect at all, there is no solution. Okay? There's at no point that I can plug in that would work for the equation of this and make it true, and the equation of that make it true. This one intersects in two spots. Now, this says it wants an example of a number of solutions as being 2, and it's a parabola and a line. Well, a parabola looks like a U, and a line, hey, look, they intersect at 2 spots. There we go. Now, if I have a horizontal line, okay, that's a line that would go this way. If it is horizontal, so y equals a number, there's no x even in the equation, then there's only going to be one solution. Otherwise, a line will always, if it intersects it, will always intersect it twice. Because of this curve, we'll have one in the examples here coming up, but it meets here, but barely, but then goes this way. It's still, this curve goes under the line a little. So unless it's a horizontal line, you need to know that if they intersect, they're going to intersect twice. Otherwise, they intersect once. So we're going to solve the system by graphing. I'm going to just graph like the first one with you, and then I'm just going to show you how to do this with your calculator, okay? You know how to graph quadratics, okay? There's no movement left or right because there's nothing grouped with x, but I am going to go down 3. Okay? Then this tells me that I take those points I asked you to memorize. I'll write them down here. X, y, 1, 1, 2, 4, 3, 9. And I have a multiplier of 1/2. So I have 0.5, I have 2, and I have 4.5. Okay, so from this start point, I'm going to go right 1 up 1/2, and I'm going to mirror it. I'm going to go right 2 up 2, and mirror it. I'm going to go right 3 up 4.5, and mirror it, and I'm going to say that that's just enough. So we'll plot our parabola. That's the first one. Now the second one, it's written just a little different than you're used to seeing. The only thing that's different is this -4 is in front, and we're used to seeing it at the back. So I'm just going to move it back there. Okay? There's nothing grouped with my x, so I move left or right, but I am going to start at -4. There's my vertex. Then I have those points, and this multiplier is what's in front of x, right? It's -2. So I'm going to have -2, -8, -18. So if I go from that vertex, I go right 1, down 2, and that's even off my graph. So it's going to be down here. I can't even plot the other points. They're not going to fit. So then I look, where does it intersect at? Well, these ones obviously do not intersect. So this one would actually have no solution. Okay? So like I said, the calculator is an easy check. You go in and you type in both equations. Oops, 1/2 x squared minus 3, and under another line you're going to enter in, it was a -4 minus 2x squared, and you graph. Or you could have typed in -2x squared minus 4. They're the same equation, just written in a different order, and they don't intersect, so no solution. Okay, now this next one I'm going to show you that they do intersect and there is a solution. Okay, so I'm going to type this in. I have parentheses x minus 2 squared. Oops. They're not putting them in the same order, but it's okay. Now the second one is actually a line. Okay, the second equation, it's not x squared, it is just x. So when I graph them, there goes the line, and there's the quadratic. Okay, now it looks, just by looking at it, like they only intersect once. Now I'm going to zoom in and show you that they actually intersect twice. So I'm going to just change my window. You don't need to do this. I'm just doing it to show you. I'm trying trying to remember what I want to change it to. Whoops. Let me see if that'll show it. Oh, nope, I need to scoot over. Sorry. But you have to wait for it to be plotted. I didn't scoot over quite. See that? Excuse me. Yep, there. We'll see it now. And then we see that graph see intersects, and that curve, it's really hard to see unless I get even closer. That curve is actually underneath that. So I'm going to get even closer. Oops, I pushed a button, didn't mean to push. See if you can see it now. So there's my line coming in. And that graph, oh, I'm too close. If you can see, the pink is underneath the blue. And so all right, so I'm going to set my window back to normal. I just wanted to show you that even though they look like they intersect once, they actually intersect twice. So even if you can barely tell it, remember, unless it's a horizontal line, like a y equals some number, they're going to intersect twice. So I'm going to go to second calculate, just like when we did when we were doing a quadratic where it crossed the axis. It's under that same menu, but we're going to go to now where these two things intersect. So number 5, and it just says pick your first curve. Now, when I'm wanting this left intersection point, I want to be left of the intersection. So I'm just picking this curve here. It automatically throws me the other curve. I just push enter again, and my guess, I'm just pushing enter again. So you push enter 3 times. And this tells me it has an intersection when x is 2 and y is 0. So I know I have the point 2, 0. So it actually intersected at that vertex of my parabola. But I want to see what the intersection is on the right side. So I'm going to push second calc intersection, and I'm going to scroll to the right of my intersections, and I'm going to put enter 3 times. And it tells me that intersection when x equals 2.25 and y equals 0.0625. And I write it down. That's my other intersection. So 2.25 and 0.0625. So you can see it is very slightly above 0, but it was still there. Okay? So now I have my 2 points where they intersection. This is solving the system. It's the 2 points I could plug into either one of these equations and it still stay true. So for 3, I'm just going to plug them in again. I have a negative x squared plus 4, and I have a 1/2 x plus 2. So again, this is a line and a quadratic, and I graph. And as long as they intersect, I know I have 2 solutions because one of them is not a y equals a number. It's not horizontal. So now, again, you can tell by your intersections they aren't exactly on a point. So I'm going to push second calc 5. Now I'm going to go over, like I said, I'm going to go over to the left of the intersection, give me this one on the left, and I got negative 1.69, comma 1.16. And then I'm going to go calculate the other one. I'm going to go past it, push enter 3 times. So my other answer would be 1.19, comma 2.59. There's my 2 solutions that I did by graphing. So in your practice, you're just going to do the graphing on your calculator. Hopefully you remember how to draw quadratics, but if you need a refresher, use those equations and get some graph paper and do it to practice. Now, the next way to solve a system, well, we'll get to that in a second, I'm sorry. Now, if I gave you a graph, it wants to know what the solution is. Okay, so this graph, make sure you realize this is the x-axis, this is the line that's graphed. Now, this line is horizontal, but it doesn't meet it adds vertex, so I do have 2 solutions. So here would be one solution, that's where they meet, and here is the other. And I just named those points. Got to pay attention to the units here. On the x-axis, it's counting by 1s. On the y-axis, it's actually counting by 2s. So this point is negative 1, negative 10. Okay, and this point goes to negative 10. Whoops, I almost wrote negative. That's a positive 2. All right. So there's where they intersect. Now, you read this graph. Where do they intersect? They don't. So there is no solution. Now we're going to solve by substitution. So we're done graphing. It's good to check your answer with graphing, but I'm going to do these by using substitution. Okay, one thing I need to tell you to make 2 changes to these problems. And I need you to take off this +1. Otherwise you get kind of a messier problem than I'm intending for you to do. And take off this y squared. We haven't done circles yet, so take that off. We want it to be a parabola, not a circle. Okay? Alright, so now I'm ready to solve these problems. Now, I have a line and I have a parabola, and I want to solve this system, and it does want me specifically to use substitution. So that just means this tells me what y equals. It tells me y equals this. So in this equation where I have y, I'm going to put this and leave the rest of the equation the same. So I have x plus 4 is going to equal x plus 2 squared. Okay? Now, I want to solve this, get this down to equaling 0, so I have a quadratic I can actually do something with and solve. So I'm going to multiply this. You can use your multiplication box, which you just have an x plus 2 times an x plus 2, so an x plus 2 around the top here. I'll just do it over here. So if I want to multiply these, I have an x plus 2, x plus 2. In this row, I have x. In this column, I have an x, so that multiplies together, make x squared. This column is a 2, this row is an x, multiplies to make a 2x. 2 times x here makes a 2x, and then I have a 2 times 2 is 4. So that's what this became. Okay, so now I rewrite it. I still have the x plus 4 equals. Inside, I collect like terms as I go. I only have one x squared, but I have 2 x's. I add them together, I get 4x, and then I have the constant of 4. Your like terms, when you multiply using the box, are always diagonal from each other. All right, now I want to get it equal to 0, so I'm going to move that x and the 4. So that's going to give me a 3x, and a 4 minus 4 is 0. Now, you can write a 0, you can use the factor box. I will tell you all of these problems in your practice and in these notes are factorable from here. If they're not, you could always use the quadratic formula or however you want. So solve by the best method you feel most comfortable with that would work. But these are all factorable. So I could use the box. I'd have first term of x squared, last term is 0, and then solve. But I can take an x out of both of those terms. And then I have an x plus 3. Now this still equals 0. So to find my options for x, I know either this is equals 0 or this equals 0. So that means x is going to equal 0 and negative 3. Now that's just x. I am not done solving this system. I have to take these x values and I'm going to substitute them into one of my original equations. I like to plug them into the easiest one, which in this case is the linear one. So when x is 0, I plug it in for x, and I have a 0 plus 4, just 4. So y will equal 4. And then I plug in negative 3 in for x. Negative 3 plus 4 is going to be at 1. So that means y equals 1. There's my 2 solutions. Again, I recommend always checking these on your calculator. So I go to my calculator. Whoops. I graph nothing. Accidentally. X plus 4, parentheses, x plus 2 squared. And because I told you these are all factorable, they're nice, pretty clear numbers. I can see it's at negative 3, positive 1, and it is at 0, 4. So I did it correctly. Okay. So the next problem here. Sorry, giving myself some space. Now, this equation tells me y equals all of this. So where I have y in this equation, I'm going to put this into there, and the rest of that equation stays the same. So I'm going to have an x squared minus x plus 4, because I substituted that into the y, equals 16. Okay, now I'm just going to get this equal to 0, so I have an x squared minus x. Now it's going to be minus 12 equals 0. All right, if you can't just factor in your head, your factor box. X squared, negative 12, first and last term. When you multiply these together, it's negative 12x squared. So it multiplies to negative. So I know one's negative, one has to be positive, but they're going to add to a negative 1. So the bigger number has to be negative. So I want to think of all the factors of 12 that add together to get me negative 1. And that'd be a negative 4x and a positive 3x. So when I factor them out, looks like that. I set each of those equal to 0, so I know x is a negative 3 and a positive 4. And then I'm going to substitute this stuff into the linear equation just because it's easiest. So if x is negative 3, I have a negative 3, okay? Because you're just plugging in for x, so that negative is already there. So that gives me a positive 3 plus 4 is going to give me a 7. And then I'm going to plug in the 4 for x. Negative 4 plus 4 is 0. Okay? Use your calculator, check it. I will tell you this particular one does check out. It's all good. But make sure you agree. Now, here I have two quadratics. Still fine. I'm still going to substitute because this already is set equal to y. So I'm going to take what y equals and I'm going to plug it in for y up there and rewrite everything else in that top equation the same. So I have 2x squared plus 10x plus 48 equals y, which is negative 4x squared minus 16x. And then I have a minus 10x still in my equation. Okay? I can collect some like terms right here. This is going to be a negative 26x. And then I'm going to move these two terms that I now have over here, and I'm going to move them to this side so I have it equal to 0. So I'm going to add 4x, so I get I'm going to add 4x squared, so I get 6x squared. I'm going to add 26x, so I get 36x. And then I still have the 48. Okay? Again, I told you everything's factorable. So you can put it in your factor box just like this, but because these numbers are quite big, you'll have to deal with some big numbers. But I can also see, to make it easier for me, that 6 goes into all of these terms. So if I take 6 out, I'm left with x squared plus 6x plus 8 equals 0. And now I can just factor this. I can ignore the 6, and I can factor this. And much smaller numbers, easier to factor. Plug in x squared and 8, multiply them together, so it adds to a positive 8, multiplies to a positive 8, adds to a positive 6, so they're both positive. They're both going to have an x, and it's going to be 4 and 2. They multiply to 8, they add up to 6. So I have an x plus 4, x plus 2. So this equation, because I have the 6 out here, it's the same thing as having it written like this. And now I solve for x, okay? Which means I set each thing equal to 0. Well, 6 being constant, I just ignore it. I want this equal to 0 and this equal to 0, so x is a negative 2 and a negative 4. And I'm going to plug them back in. It is always easiest to plug them into the equation that says y equals. In this case, I don't have a linear one, so I plug them in to this quadratic that is already set up y equals, okay? So when I plug in negative 2, and I take negative 4 times negative 2 squared minus 16 times negative 2, and I don't know why I wrote 12 down here. I'm sorry. Negative 2. I'm going to get 16. Now I'm going to plug in negative 4. So I plug it into there. I'm going to get 0.